Hello, everyone. My name is Egon Ba. I'm head of infra at XYB. So I'm here today to talk about how to build a robust coreless platform for the future. On the second half of the presentation, I'm going to be doing a couple of presentations or demonstrations, how we're doing things. And keep in mind that those are actually small building blocks of the bigger ecosystem. So who we are? We are a technology company with extensive knowledge in banking and financial services. And we are committed to create truly composable and scalable banking platform. We are empowering our customers to innovate at speed and reduce complexity. So our platform consists of different domains. It's modular. And in our portfolio, we have multiple domains which customers can actually choose. You can choose only one component, or you can choose actually all of them. So it is truly composable, and this gives customer ability to choose what they actually need. Each domain can contain multiple services. Those services can have also multiple components. So, yeah. I think it's really important to actually go through the life cycle of the platform because we are thinking ahead what we need to do in later phases. So we have identified 4 major phases. First one is preparation, bootstrapping, maintenance, and end-of-life phase. So each phase has its own things. In preparation phase, you create your cloud infrastructure accounts. You create your commercials if you need to do integrations with different partners. So there's a lot of preparation in the beginning. It takes time. It can be quite time-consuming. The bootstrap phase is something that we focus currently quite heavily. In that phase, we establish CI if it's needed. We create a platform domain if it's needed. We are provisioning all the resources. And on top of that, we configure platform for the customer needs. Sorry. So maintenance phase is the longest by time. In that phase, we have to do regular maintenances. We have to do releases. So we have to take into account this thing currently. We need to plan for it. And of course, the end of life, like everything, we need to think about all that also. So there is multiple scenarios there. Maybe customer wants to end contract. Maybe customer wants to take ownership of the account. There is different ways of doing that. So we are preparing also for that scenario. So future-proofing platform, there are a couple of fundamental things that you can start thinking right away. First of all, I want to stress out that it's actually collaborative effort and agreement between different stakeholders, different teams, different engineers. So it's agreement between them. So for us, there was 2 really fundamental things, standardizing infrastructure and applications. So We have been using a lot of modules. We use currently Terraform, but we are shifting towards OpenTofu. And this is managed by Spacelift. So Spacelift gives us enough freedom to actually do multi-cloud. So, yeah. Definitely use Helm charts if possible. It's quite easy nowadays to generate Helm charts. And this gives you freedom to actually compose different applications into your stack. There is one thing that you need to be aware is that if you bring in dependencies. So if you're building standalone environment, be aware of your dependencies. I mean, everyone knows the chicken and egg problem, and I'm pretty sure that you guys can deal with those issues weekly basis. The other one, what is also quite like low-hanging fruit, is create your own naming conventions. So across organization, agree how you're actually creating service names, how you create databases, how you do DNS zones, all that kind of things. It is definitely initial effort, but in long term, it's worth it. Everyone knows, for example, if AWS gives you some permission issue or error, it would be good to know right away from the error itself where it came from. You don't need to ask which environment. Everyone knows. So you can read already, if you have good naming convention, that this environment has this issue. And AWS messages are quite readable in that sense. So why GitOps and FinOps? So I have a question to audience. How many of you are actually using GitOps in production? Maybe you can raise hands. Okay, that's pretty good. Half of it. Yes. And how much are actually doing FinOps? Nice. Okay. Right. So there are tons of reasons why to choose GitOps. For us, it is consistency and speed of delivery. I just brought up two top of our mind. So FinOps is equally important. For us, it's important to understand what is our cloud spending. So it's as important as speed of delivery, or consistency, or availability, or resilience. So, yeah. So I just want to tell you all that we are also using GitOps in obviously managing infrastructure, managing our build pipelines, or managing applications. So everything is codified in like 3 major areas. Regarding cost and capabilities, we have been approached multiple customers who always ask, what is the cost? Always. It's same as they're asking what capabilities you have. So we are expecting them to already ask that. But there is always conditional things. What do we enable on that environment? Do we enable AZ for resilience? Do we need to enable outbound firewall rules, which are costly? What kind of instance types are we using? What kind of load are we using? So this is where we need to start mapping out our capabilities and cost. So it is target cost versus actual cost. So we need to start having that baseline understanding of how much things are costing. We are recommended always to use also cost estimators. I know that different platforms have different capabilities, but for us, Spacelift has this cost estimator, cost infra plugin, which can provide you when you ever provision new resources. So it's a useful tool. So there is one more thing I just want to raise here at the cost topic, is that whatever you put into the cloud, it needs to have lifecycle. If you're uploading image or something, some document or anything into cloud, what is its lifecycle? How long it's going to stay there? Can we delete it after 2 years? Do we need to keep it 10 years? Would that bucket actually grow without end of life? So yeah, I challenge you to actually think about everything that you put in cloud. I'm going to briefly also go through consistency problem. For us, the challenge was to keep consistency. But here are the couple of tricks that we use to ensure that. I briefly mentioned standardization of infra and deployments. We keep source truth in Git. We enable drift detection. So briefly also was mentioned that some of the engineers have seen drift detection. So you need to later on mitigate that. One of the things is that we don't actually have escalated privileges in our environments. So we use only Spacelift to manage or change things in cloud. If there is a need for escalated privileges, then we have a way to actually request access. So we are doing JIT. I want to bring out also the validation of your platform creation. So if you say that your environment is fully automated, are you really confident on this? Can you actually destroy it and recreate it? So we have a validator. So we use Spacelift scheduler to actually bring up an environment in the morning and kill it on the evening. So this way you can actually pick up changes who is doing anything manually. Like if someone sneaks in, gets escalated privileges, and does something in, I don't know, HashiCorp Vault, or puts something into AWS infrastructure, this will be removed and recreated. Will it work next day? So yeah. So one of the topics on my talk is multi-cloud. So we are supporting currently 2 major providers, AWS and Google. It provides us wider global coverage. So we are capable to deploy anywhere in those co-locations or regions our stack. In future, we could add Azure and IBM, but we acknowledge that it's not like really easily doable. You need to have knowledge in-house to support that. And we have been using also contractors to actually bring in more knowledge, cloud-specific knowledge, for example. Here are our main drivers for multi-cloud. Of course, number 1 is customer requirements. Customer always has its requirements. So there is always one regional presence of the cloud provider. The regulatory compliance, like was earlier talked also on about DORA. So, yeah. Resilience in general also. Reduce vendor lock-ins. So with going to multi-cloud, you actually reduce significantly your specifics on cloud. For example, we don't use any more AWS SQS, SNS. We moved over to Kafka. And of course, cost. So that's extra benefit, which will come on later, where you can have 2 sites running. One is on cloud, in GCP cloud. The other one is in AWS. You can actually start comparing prices. So that's something. I just want to bring out a couple of major incidents about resilience. So 2024, there was Unisuper outage where customer was without cloud account roughly 11 days. And the other one was Atlassian outage, where also we were impacted and our Atlassian was unavailable for 2 weeks. So in finance, this outage can be actually catastrophic. So we can't afford to be on that long outage, basically. So, presentation part. I'm going to share some demonstration here, how we are doing Spacelift and how we are provisioning infra resources. But keep in mind that this is just a little sample of the whole, from the whole ecosystem. So it is how we are provisioning service-specific resources in Spacelift. And I'll also briefly show Spacelift itself. So, yeah. So this is the Spacelift Spaces. It's similar to OUs in AWS, where you can create your own structure. Here we can see GCP tree and regional tree. And on the lower layer, you have actually accounts. So this is all automated, generated automatically. But yeah, this is the spaces. And in spaces, you can define permissions. You can inherit different things. So yeah. In next slide or on next, we're going to show you how we are doing different stacks. Stack is collection of resources. So admin stack is actually creating all the sub-stacks where we manage different resources. And it is important to understand the dependencies. So if you get the dependencies resolved, it's easier to manage. So try to avoid unnecessary dependencies. This is now a dependency tree between different stacks. So we have networking, DNS stack, Kubernetes stack. They are standalone resources. They just will come up, and you can continue building on top of that. We have dev, breach stack, which is actually between different accounts. You can do integrations. Helm stack is where we install CRDs, and in pre-services, we call this preparation services. Or, for example, Vault, we're talking about Kubernetes, we're talking about different those services. Services stack itself is where we actually create resources for AWS. So it's like infra resources for the service, like IAM role, Redis, and so on. And here we have actually one pull request where we define our service. It's just what that one single service needs. And we can see that it has different types. It has backend, it has DB migration, and it had micro frontend also. pull request is always tested before we can merge it. In the next window, we can see that this pull request will create 31 resources. There is database, ECR, Redis creation. Just for information, we're using a lot of objects or arrays in Terraform, what we actually iterate through. So we have a lot of maps, we have a lot of like capabilities to override certain parameters. So we are using arrays. So after merging the pull request, we can see that Spacelift automatically picks up the change and starts to apply changes to the environment. And this is all happening inside Git. So a change was added to Git, and this will trigger the actual resource creation. Here we have creation of the resources. AWS Redis instance and RDS instances creation is taking quite a lot of time. You guys already know that, so I had to skip some of that things. But yeah, this is how we do one single service component in our ecosystem adding. Secondary, if you remember, there was dependency from service to database stack. Now, database stack is going to go and pick up that services map, and it will recognize, oh, I am missing that part of the map. I need to create one. So database stack now will go and start creating database instance. And here we can see Redis instance created and database created. And they are, of course, following our naming conventions. So yeah. So yeah, that was just a sample how we're doing one service with different components provisioning. It has IAM roles by default. It has Redis if it's needed, database if it's needed. So there's a lot of defaults defined. But as you saw, there was possibility to actually override certain parameters. So, yeah. And we also have a demonstration how we are doing now Helm chart deployment. We have in-house built Helm chart for our microservices. So I'm going to demonstrate how we are adding Helm chart for the microservice. So we identify every service with code name. So it is unique across the organization. It has service types. You can see here it has version. There is certain external secrets which are required. We can define here ingress, DBM, MFE. MFE is micro frontend. So that's also in here. And we are actually using Kafka to do event-driven architecture. So we want to have asynchronous communication between different domains. So once we merge that Helm chart YAML file into trunk, we can already see that Argo CD will pick up the change. It will start to provision different resources. Here we are looking at Kafka user creation, password creation, topics creation, things. And we are using Streamzy Kafka for quite some time now. And here is the microservice deployment. We see external secrets generated. We have jobs, so DB migration and micro frontend are jobs. And in the terminal also we can just now see that jobs were completed and backend services running successfully, already for 4 minutes. So that was a presentation how we are doing things. It has simplified significantly interaction with developers. Developers are really comfortable doing pull requests, and currently we have been doing kind of reviewer role. So we review things, we agree them, and we put this into Drunk, and the resources will be automatically generated for them. But keep in mind that this is only a small part of the bigger ecosystem. So this was just one service sample how we deploy into the environment. So, yeah. All right, that was my short presentation. I know that there was a really brief introduction on that. If you have any questions, let me know. But yeah, I want to thank you for listening, and hopefully it was interesting. Thank you.
Thank you. Any questions right now from the audience?
Hi there. I have this question that for developers to make pull requests, they have to validate their pull request beforehand. Do you have a separate environment for that, or do you use additional tools so that developers can make like proper pull requests and not disturb or waste your time?
So, good question. So in infra side, we have automatic space lift planning goes through. So this is ensured with that. But from YAML perspective, it's more loose, I would say. So that's why we do this currently reviewing part. But I mean, there are tons of samples for them. So that I'm quite confident that they are really good at like doing YAML structure of the file. So yeah.
Okay, thank you.
You mentioned this infrastructure costs evaluation, but does it include the Kubernetes stuff? I mean, is it only calculating AWS cost, but what about deployments?
So currently we're talking about cloud costs. We don't have that detailed information on Q cost. I know that there's a tool for this, but yeah, we still need to. It's quite a new thing to us also, so we are not there yet. So yeah.
Thank you.
So let's have a round of applause, and thank you, Egon.